Hello friends, welcome back to the channel. Semiconductor chip manufacturing is a most complex industrial process. It requires atomic material, it requires precision tool, it also requires months of work and most importantly $1 billion of investment. So as semiconductor chip shrinks below 3 nanometer technology, it becomes harder, it becomes slow, and also it is prone to defects. So there lies the importance of application of artificial intelligence and machine learning in the semiconductor manufacturing. So in this video we talk about 5 key areas of the AI/ML impact on the semiconductor manufacturing. We'll also talk about the real world top chip manufacturing companies, how they leverage AI and ML in their semiconductor manufacturing. We also see that after the application of the AI ML, what is the result that is generally obtained from the chip manufacturing process. So stay tuned till the end of the video to know all about this. So let's talk about 5 key areas for the AI ML impact on semiconductor manufacturing. So first start with defect detection. So generally the wafers from where semiconductor manufacturing starts, it is basically the AI ML is trained with thousands of images of this wafer so that it can identify microscopic defects on the wafer surface, and in this way it can catches flaws and improve the chip quality drastically. So this is the defect detection by the AI ML. Second thing is basically the lithographic optimization. So lithography, I just would like to give you a small background of this. In the lithographic process, there are big lithographic machines, and from where there is a chip design blueprint is put on the aperture, and a ultraviolet rays passes through the aperture and makes a image on the wafer surface, and the wafer is already coated with the photoresist material. Now generally, even though there is a perfect blueprint of the AI chip, but the actual image that is being put onto the wafer surface with coated with deposition and the photoresist coating is not ideal. So what is done is basically there is some tweaking is being done on the blueprint of the chip, so that even though the blueprint is not 100% correct, the chip projection on the wafer surface is good and 100% correct. So there is a trial and error kind of process where by tweaking the process, generally the good chip is being prepared on the wafer surface itself. So what it does is basically the machine learning and AI ML based on the historical data and also the process, it improves these trial and error situations and helps to prepare good chip on a particular wafer. So this is basically the lithographic optimization. Next thing is basically the process control. The other processes on the semiconductor manufacturing like deposition, photoresist coating, and also the etching. So this is being monitored real life by the AI ML. So this helps in reduce the waste and improves the speed of the process. So this is the process control. Next thing is basically the yield prediction. So yield prediction generally happens that based on the advanced node, as I talked about that below 3 nanometer it's going to be more difficult to prepare the chip by shrinking the transistor. The yield is not good for the new node. So even though 60%, 70% of the chips are found to be good on a particular process node of technology. So AI ML helps in the yield prediction. So what happens that based on the historical data, it finds that how many good chips can be obtained from a particular process node, and based on that the semiconductor fab prepared for the number of chips that it is going to fabricate for a particular customer. So generally nowadays the chip design companies They prepare chip for their own design process as well as for the third party manufacturing. So they should know that how many chips within how much time interval they can prepare on a particular process node. So AIML helps in that for the yield prediction. Next thing is that design to manufacturing cycle. So what happens is that the chips are first designed and then they are put on the manufacturing process. So AIML is basically fed with EDA. It basically links the EDA tools. EDA is basically the electronic design automation that helps in the design process of the tool. It links the EDA tools with the manufacturing data so that the flaws are being identified at a very early stage, so that the design to manufacturing cycle become less and the chip process of manufacturing becomes faster. Now let's discuss about the real world examples, how the top chip manufacturing companies are preparing the AI chips and using or leveraging AIML stages of chip manufacturing. First start with Intel. Intel has a 18A node that they are working on in 2025, and they use defect detection and lithography in the 18A node process. Second, let's talk about TSMC. TSMC is basically they have multiple fabs, and these fabs are AI enabled to manage 3 nanometer, 2 nanometer technology. They are currently working on 3 nanometer, 2 nanometer technology. 3 nanometer is already on the production. So it helps the process control and yield prediction, by which they improve their process in the fabrication step. Next is basically Samsung. Samsung has gate-all-around transistor technology. So they use AIML to improve this gate-all-around technology to prepare AI chips. NVIDIA has a complete process. So they has all the design process, they have all the chip fabrication. So they use primarily the AI and ML on their design process. They basically use the chip development pipeline on the chip. So specifically logic synthesis and verifications, they are deploying AIML out there. Broadcom prepares a network chip. So they basically leverage AI to optimize packaging side of the chip. So packaging is also part of the chip manufacturing process, that they basically use AIML for the packaging and interconnect between chips, so that this helps in the network chip fabrications. So these are the top chip companies. I talked about Intel, talked about TSMC, I talked about Broadcom, I talked about NVIDIA, I talked about Samsung. So these top 5 companies of chip fabrications, they are deploying AIML in the chip manufacturing process. Now let's talk about what are the results they get after AIML deployment. Till now, AIML is also basically changing their algorithms. Till now, they have on the design cycle of the things, they have improved it by 40%. 40% is huge number. So 40% faster. That means based on the AIML deployment, they get 40% faster turnaround of the chip manufacturing. Manufacturing yield. As I talked before that this AIML helps in the manufacturing yield detection. So that improved 10 to 15% for these companies on an average. Now this AIML help to reduce the rework, and also time to market becomes more faster by employing this chip manufacturing process. And most importantly, it significantly reduces the cost of manufacturing. So after the chip manufacturing, what are the pricing of the chip that basically determines is being determined by the chip manufacturing process. So that is basically improved a lot. So these are the 4 or 5 improvement that has been still obtained by deploying AIML in the chip manufacturing process. So let's do a recap of whatever we discussed till now. I talked about what is the semiconductor manufacturing, why AIML deployment is required in chip manufacturing. I talked about there are 5 key steps by which AIML can be deployed. I talk about real world examples, how the top chip manufacturing companies are deploying AIML. I talked about what is the impact or what is the result that has been obtained by deploying this AIML in the chip manufacturing process. So I hope you get some ideas about the AIML technology and in the deployment in the semiconductor manufacturing. So what is your thoughts till now? By the way, I should mention that based on several requests from the audience, I have specially curated today's video. So there is request that how AIML can be deployed in the semiconductor manufacturing by many of you. So thanks for your comments and feedback. And also based on today's discussion, whatever you think, do you think any other impact that can help in the AIML deployment on the semiconductor manufacturing? Please drop your comments in the comment section of the video. And also if you want to me to discuss something apart from this, so also that mention in your comment section of the video. And if you like these videos, please subscribe this channel to get similar videos like that. And also I would like to mention that I have recently launched a book called Semiconductor for All, and that discusses different semiconductor discoveries, different semiconductor topics, and also artificial intelligence impact on the semiconductor. I also mentioned about described different semiconductor manufacturing stuff out there. So I would suggest that you should buy this book. The link of this book on the Amazon I will put on the description section of the video. So I think that's it from my side for today, and wait for the next video to come. Till then, Subhasish Chakraborti signing off.